What's up everyone, my name is Ben and you're welcome to my C programming language tutorial. Okay, for those of you all that have not yet subscribed to my YouTube channel, please head over to https://youtube.com/@hackpeace. Okay, the link you are seeing on the screen is the link to my YouTube channel. Please make sure when you subscribe, turn on the notification bell so that you receive notification whenever I drop a new video. Okay, so the purpose of this video is to teach you guys data structure in C programming language. However, any language you are learning, okay, there is need to know data structure because it will come to a point whereby you need to write a productive programs or a program that the individual or the society is going to be using. You are going to make use of data structures, okay? But basically this is going to be on the C programming language because a lot of you guys that are electronic engineering students, those of that are software engineering students writing servers, networking 5, or you want to build operating system from scratch, writing browsers and lot of things, okay? This video is for you. And also for newbie, I will do my best to simplify everything to your understanding. Okay, so without further wasting of time, let's dive straight into what this video is all about. So I'll press Ctrl L to move my screen upward and Ctrl U to clear up the whole text. Then the next thing I'm going to do here is using the mkdir command, okay, and to create a directory called link. Okay, I'll call this link list. Okay, link list. Okay, so if I press enter, you can see nothing happened, but actually something did happen. A directory called link list is being created. If I do ls, you will see link list in blue color. So I will just do cd to link list. Okay, if I do cd to link list, press enter, I'm inside that directory. So I clear my screen. If I do ls now, you see there is nothing inside this directory. Okay, don't be confused guys, the directory is just an empty directory. Okay, so what we are going to do next is to create file where our C program is going to live. So we use a command called touch, okay, and we give the name of the file the link, okay, list. Oh, that was wrong, we should spell linklist .c. Make sure you put the .c at the end of the name of the file. Why we put the .c is to tell our CPU that this program we are writing is not a regular file, is a source code in C programming language. So therefore CPU handle this file as a C extension file. So we press our enter key and that file is being created. ls and we can see linklist.c. Okay, a lot of you guys out there normally use different editors. Most of you use IDEs like the Visual Studio Code, like Sublimes, like Notepad++, like Atom, okay, and the rest of them. Okay, basically, I like using the CLI, which stands for Command Line Interface Editor, and the pretty one I like using is called the Vim editor. Okay, and Vim is normally installed or usually installed by default in any Linux operating system. Okay, but if you don't have Vim installed, you just type super user do apt-get install Vim and you hit your enter key and it's just going to install Vim. Okay, and that is it. So already have it installed, so I won't be installing it. So I clear my screen, Ctrl L, and I'll just do Vim, which is my editor, and I'll give the link list the name of the file. When you type something in Linux, so example, I'm typing the link list, I'll just type just a little bit hyphen of the name of the file and I'll just press my tab key, it auto completes it. That is one of the powerful features in Linux. So I press my enter key. Now we are in the Vim mode. Okay, now that we are in the Vim mode, we can't type anything because we don't have read and write access to this file. So for Vim to give us read and write access, read and write access means that we can code inside this Vim and it will reflect to the linklist.c file. So we just press the I key for that. Now you can look at the bottom left of the screen, it's changed to what we call insert. Now we can type our code. All right, I need to include some header files, some macros. Okay, and this macro should be called inclusion of name files. Okay, so I will say include, it should be called inclusion, it should be called include. Okay, and I'm including stdio.h. stdio.h give us access to use the print, okay, the printf function or the file printf function, or the scanf function, or the fscanf function, or even the put sha or the get sha, so and even the p error. Okay, so these are pretty much what functions, and there are tons of them that the stdio.h allow us to make use of. Okay, so those are the functions. I'm also going to include another header file. This one will be called the stdlib. Okay, this function stdlib function header file, sorry, stdlib.h header file allows us to make use of the function called malloc or calloc. Okay, so these header files allow us to allocate memory size for ourselves. Okay, so this is going to be a linked list. So we are going to be doing what we call first called the single. So I'm going to put a comment, single link list. Okay, single link list in C. So I'll just comment that out. So to create a single link list in C, we have to create a struct. Okay, so I will say struct, and I'll call this struct to be of node. Okay, example of what node means. You can check your dictionary of what node actually means. Node is like a block of code that holds a value and an address. Okay, when you create a let me just comment it, say node holds, okay, it holds data and address. Okay, that is what simply a node do. It's just a name though. So this name, this struct of node, we have a member called data. Okay, having called data, and a structure of node that points to itself, and it should be called link. Okay, semicolon, and I press my enter key and I close this. Okay, we can as well like pass in node at the end there, so that we don't need to include struct when we are making or referencing or allocating memory storage of this structure of node. Okay, but for simplicity I will just take this off. I'll just put my semicolon. I will do the int main open bracket, I pass in void. This is a very good practice, that when you are not accepting any argument to your main parameter or any function parameter, please make sure you pass in void. Void simply means there is no data type. So I will just comment that void means no data type assigned. Okay, that is simply what void means. Okay, so I press my enter key. Okay, let me just put a open curly brace up here. I just like using this style of coding. Press my enter key, type return 0, because always I'm returning something to main. If I would have do void here, like this, that means there is no need of returning anything. But because our code we always check for error, so it's always good to return something. That's why I'm returning an integer. So we come into our code, the main body of our code. All right, so next thing we are going to do here is that we are going to create a structure of the node to access the node from the main function. So we say node should be a pointer of head, okay, comma, and current. Okay, and the current also should be a pointer. So we are creating a structure of node of pointer called head and current. Okay, if you are confused about this, I can just simplify it for you to understand. I can do first structure of node pointer of head, another structure of node pointer of current. Okay, is simply the same thing. Okay, probably maybe I will just leave it like this so you guys can understand it. So then what I'm going to do next now is that I'm going to use the first, which will be the head, that will start up the first node. Okay, remember I said at the top here that a node holds a data, okay, a data, or should I say a value a value, okay, and address. Okay, so now we are creating a node that will hold an address and a value. So we say node is equals to, remember that this head here, which is struct node of pointer head, is a pointer of struct. Okay, so of struct node. So therefore we will always return a struct here to it. So we'll do a typecasting in C of node pointer, and we close this with curly with brackets, and we call the malloc function. Now we are ready to allocate a memory storage for ourselves. So we get the size of what we want, and the size of what we want is the struct of the actual size of the node, which is 8 bytes, and we close that. Okay, so the next thing here is we need to check for errors. I love to check for errors whenever I'm writing code. So I will do head. If head is equals to null, okay, if head is equals to null, then we encounter an error. Then I will use the p error, and I'll pass in quote space quote double quote close. The reason why I like to use p error most times is because it handles the error for me itself. So if I encounter error, it will be a very good idea that I free this head of struct node head, which we allocate a size of 8 bytes. So we free it, and also when we free it, semicolon to denote the end of that, and we return to the main one, and that is it. So if everything works fine, then this statement here inside the if statement will be ignored. Then our code will move to the next line here. Okay, and I know that this thing will be very, very right, so there will be no need for errors. So everything is going to work fine because I know what I'm doing. So the next thing here, we say head pointing to data. Okay, head pointing to data is equals to 100. So now this value we hold and 100. Then we say head should point to link. Okay, and this link now, since we don't have any other node, let it point to null. Okay, the word none here, let me comment. The word none here means point to nowhere. Okay, it means points to nowhere. So that is what basically that is doing. So we write a simple print that can print it. So we do print, and we say head.
Are you interested in learning the fundamentals of?
We say head is pointing to data. Head is pointing to data. Say equals to %d \n double quote comma, and we say head is pointing to data, and we close. So if we run this code, is basically going to print the head pointing to data is equals to 100. So before I run, I would like to free at the end the head. Okay, and also I need to put a semicolon there, and also free current, because there are two structure of node, which is head of pointer and current of pointer. So we also free current. And even at the top here, even though we check for errors here, okay, so I shouldn't free current now because there is no memory allocation for current, so I will just leave current for now, just free head. So let's run this code and see if everything works fine. So I will do gcc minus uppercase WALL. I'm writing this code to be a professional one, so that the compiler of C will be so smart to detect errors for me. So I will do minus again uppercase WS extra minus G, and we'll call the linked list.c output to linked list, and remove.c. So this one in here we include, we make our program to be very, 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 very clean and very well written code. Okay, so we compile, and the minus G there is to include for debugging, so that if you wish to debug our code, probably if we find any error or any place that something is going on we don't understand, we can debug it as well. So I press enter and it compiles. Oh, we got an error though. Okay, let's go fix that. All right, so I will just go back to the code I for insertion. Say we have error here. So what is the error? So pointer of current. Okay, head error data we print. Okay, the problem is that we create a structure of this, maybe probably because we are not using it. So let me comment it out for now. So we compile and it compile. Why? Because those structure we are not using it. So because we added this warning, so it's giving us those error because our program is made to be very clean and correct. So if you do ls now, we have link.list. So we do /link.list, and probably now we should have our data head pointing to data equals to 100, and that is it. So everything is working fine now. So we go back to our code to create more nodes. Okay, so link list.c, which is our source code. We go back there and we uncomment this now, this node of current. Okay, so we uncomment it and we need to make use of it so that our compiler don't complain. So at the bottom here, before the print, we will now say current, which is of pointer. So therefore this node will return pointer. This is what we call a cast. So we say struct of node, which is pointer, we close, then we call the malloc function, and the size of keyword, and we say what size is the struct of node, the struct of what node, and we close this semicolon. We check for errors again and we say current this time around. Okay, you say current if is equal to null. Okay, that means we encounter error, or pp error, open double quote space double quote close, and because we encounter error, we need to free this. One of the reasons why we free is because when we don't free a memory we allocate for ourselves, the CPU or the computers or the operating systems assuming that memory is still in use, and by allowing that, it makes our memory storage to full or make our computer run slow. So it's always good to free a memory you allocate for yourself. So I will be freeing current, and also free head, because head is also allocated a memory. Okay, so free current and free head, and we return 1 semicolon, and we close this. Okay, so this is it now. So we have this well set up and we press enter. So now what we can do next is to start giving data to the head, to the structure of the data element. So we say current should point to data, and this data should be equals to 200. I will say equals to current, now pointing to link, which is a struct of the structures, the structure which have a struct of itself that point to itself, called link. So this should point to null. Okay, this should be assigned the value null, and we say this time around we want to link. If we do not link, we need to create different printf for each of the node. Remember I told you every node we have values and address. So if we do not link this second node with the first node, that means there will always be a separate printf for them, and I don't want it to be so. I want just one print to print every of those nodes and their values. So I will say head, which means starting from the first node, which is head, and point to link. Okay, now link should now be equals to what? To current. Okay, so now this will make head pointing to link to hold the address of current. So for this to print, we need to create an iteration here. We use the while loop. So we say while, open bracket, we say head. Yeah, we say head. While head is not equals to null, okay, then everything works fine. And if you look at this code here, the last code here is not equals to null, so it's equals to an address of current. So since it's not equals to null, then this prints here will now execute. So we have to put this in a tab. and go to the end of it and press enter. So the next thing we are going to do, we are going to say then, since it's not equals to none, we have print the first data of the first node of head. So we want to print the second node of current. So we say head now will be equals to head itself, and this should point to links. And link here, remember that link here is pointing to what? This link is pointing to current, the address of current. So with this now, head pointing to link, we can access the current. So we put our semicolon, press enter, and we close this. So this will actually works and give us freedom. So at the end then, since we are making use of current, we also need to free current as well. So we say free open bracket current, and we close this and semicolon. So let's go run this code. We compile and this. So bring up that compilation gcc /-wal, which is include all warning and include all extra warning. Then -g for debugging, and the linked list.c output to the linked list of binary file, and it compiles. ls, we have our executable code, do./linked list, and we should have head point to data equals to 100 and head point to data equals to 200. Now you can see that. So this is basically very good and clean. So let us add more node and make it up to 500 values stored in that same one single variable. Okay, so I will just bring up the linked list. Okay, and at the print here is where I'll be doing everything. Okay, at the print here is where I'll be doing everything before the y. So I press here, I press enter. So I will make use of the same current. I'll say is equals to, okay, open bracket struct of node. Remember it's a node, so we close that. So that is what we are returning. So we say malloc open bracket. So we say struct, we should give it a size. So we say size of struct node, we close, semicolon. Then I will check for errors again. I will say if current, so this is another node, please. If current is equals to none, open bracket, then we say p error open bracket double quote space double quote semicolon, and we free again because we encounter error, current semicolon, and we free again head semicolon, and we return 1 because there's an error, and we close. Since everything worked fine, we say current is pointing to data, and this time around I'll give it 300. Okay, and we say the same current will now point to link and equals to null, and this time we say head points to links. This is where the magic is, and we also, the link should point to another link again, and we say equals to current. Okay, and that is it. So we do another one. Okay, we do another one to, we say again current, we create another memory allocation. Current is equals to open bracket struct of node, which is a pointer, we close, malloc. Okay, and we say size of struct of node, and we close, and we say if current is equals to null, that means we encounter an error, we close, then we say p error open bracket, and we close, and we say free current because we encounter error, and we also say free head because we encounter error. Most people don't like checking for error. Why? Because they are lazy in typing, but it's always good to check for error, guys. So we say since main has something to need to return something, we return 1, which indicates an error. Okay, and we close this. So we say current points to data equals to 400, and what do we do again? We say current point to link, which equals to null, and we say head this time around to join the node link. So this is the third node, right? So, or the fourth one, it should be third one though. So we say link point to link. So let's check it before I make mistake. Okay, so it should be 3 links this time around. So we say link point to link, and this point to another link, which is equals to current semicolon, and that is it. So we do the last one again. We say current, I just want to make it a 500 values, so we say struct node of pointer, that's what it returns. So we say malloc open bracket size of, and we give it the struct, and we close semicolon if current is equals to, and we open bracket, we encounter error, and we close semicolon, and we free current because there was an error, and we also free head, and we, because we are returning something to the main, so we return 1 semicolon, and we close. So the last one should be, say, current pointing to data equals to 500, and I can say current pointing to links, which is equals to null. Then I will now say head. Now from the head we connect the first node, which is okay, from the second, from that first node we connect to the second node, we connect to the third node, and we connect to the fourth node, which is equals to what? The address of current, and that is it. Okay, so guys, this you guys may say I was just busy like typing, but it's pretty very easy. This is what we wrote a very sweet program. So everything we are doing is just here, this same one data we hold 100, 200, 300, 400, 500, just using one data, and that is the beauty of linked list. So this is it. So this is all the code. You can pause the video to look at the whole code, follow. Okay, and if you want to learn the C programming language, you can just chat me, or let me just at the end here put another printf to print my number. If you want to learn C programming language, my number is plus 234 913 216 5565. Okay. Say my WhatsApp number. My WhatsApp number. Okay, so that is it. So I'll just put a new line at the end, /n, and finish. So let's go and compile this. So bring up our compilation. Kaboom, everything works, no errors. Wow, today I didn't make any typing mistake. That's so impressive of me. Wow. I really like that. So run the code. You see we have head pointing to data 100, head pointing to the same data 200, head pointing to the same data 400, head pointing to the same data 500, and you can see at the end my WhatsApp number is +234 913 216 5565. So if you want to learn the C programming language, you can chat me on WhatsApp with this number and I will reply you immediately with immediate effect. Okay, so if you really want to learn, so you are welcome to join my academy. My name is Pen and it's been education hanging out with you guys. Please make sure you like, subscribe, turn on the notification bell so that you receive notification whenever I drop a new video. Have a nice day. Bye. Be blessed.